One way to plot a circle is with the parametric equation cosine t sine t. So x is cosine of t, y is sine of t. And that's the exact same syntax as we've been using in MATLAB for plotting. So let's try doing that. So first I need my t vector. Okay, I want to plot like cosine 0, sine 0, then cosine maybe 0.01, sine 0.01. Okay, and going on like that. So let's do an example. Say I do t. Okay, last time we used linspace, and that's probably better, but just to see something else, let's say start at 0, go up by 0.01, stop at 1. Okay, so what's this doing? It made a length 101 vector, starts at 0, goes up by 0.01 each time, stops when it gets to 1. And then my x vector, let me say x is cosine of t. And I'm going to suppress the output by putting a semicolon after it, so I don't get this big thing printed to the screen like I did here. Okay, but it still worked, even though it didn't print anything. We can see it over here in the workspace. And I can do the same thing, y equals sine of t. Okay, and now I can plot these two. So what I plot, I don't write down t anywhere, but it's implicitly used when I write plot xy. So what happened here? I started at 1, 0, and then I started working my way around the unit circle. Okay, but I didn't get all the way around the circle because my t just went from 0 to 1. So that's like I went from 0 radians up to 1 radian. Okay, and how many radians should I do if I want to go all the way around the circle? Okay, I should do 2 pi. So let me redo this whole thing. And let me go back to linspace now. Linspace is the better one. So let's start at 0, end at 2 times pi, and let's use 100 sample points. Okay, so there's my t. I'm going to end it with a semicolon so nothing gets printed. And now I do x equals cosine t. I do y equals sine of t. Okay, and let's try plotting it again. Plot xy. Okay, now I get the full circle. What if I wanted to have the circle with center at 3, 1 instead of at 0, 0? Well, it's actually really easy. Let's try it. So I want the center to be at 3, 1 instead of at 0, 0. So how do I do it? Well, I want to shift all of the x coordinates by 3. So I'm just going to say x is the old x, but shift all of them by 3. And let me say that y is the old y coordinates, but I shift all of them by 1. Okay, now let's try plotting it again. So it looks exactly the same, but if you look at the axes, you see that now we're going from 2 to 4 in the x-axis, and now we're going from 0 to 2 in the y-axis. What if we wanted to have more of a global perspective? Like what if I wanted to zoom out so I saw the axis from -10 to 10 in the x and y coordinates? How can I do that? Well, I'm going to use a new term that we haven't used before called axis. And how it works is I tell it what's the minimum x value I want, what's the maximum x value I want, what's the minimum y value I want, what's the maximum y value I want. Okay, so axis, it takes as input a length for, oh, I see I used an equal sign instead of a minus sign. I fixed that now. It takes as input a single term, a single vector, and that's a length 4 vector with x min, x max, y min, y max. Okay, so I just type that, I evaluate it, and now when I go back to the plot, it's going to be zoomed out, so I'm seeing from -10 to 10. So now it's a little more obvious that this circle has been shifted, and it's no longer centered at 0, 0.